Alright, how's it going, everybody? It is July 17th, 2018. Today, I'm going to be focusing in and around Yellowstone. However, the main area we're going to be looking at is the Norris Geyser Basin, which is home to the Steamboat Geyser. The main reason I'm going to be focusing in on this area for today and my future videos about Yellowstone is because it's known as a weak spot. So, Norris Geyser Basin basically has fault lines all throughout it, and geologists in general are always worried about earthquake activity over an area of shifting terrain, and so that's exactly what we have at Yellowstone. So that's why I'm going to keep my eye on it. I had went over this report that was posted Monday, July 2nd on 2018. Really wasn't anything worth mentioning or even reading. However, there were some scientists that were able to observe Steamboat Geyser when it erupted, which I guess is kind of notable. However, I wanted to mention down here as well that the ground deformation and stuff, subsidence of all parts of Yellowstone caldera continued throughout June at rates of a few centimeters per year, pattern that has been going on since 2015. Nothing too crazy. Yellowstone earthquake activities remain at background levels. I'll have that link so you can go over it. They update it just every great while. Since there's not too much activity really going on there at Yellowstone other than the Steamboat Geyser, it's really not much for them to be updating on. However, independent people like us, we can do our own updates, our own daily updates, and get an idea of what's going on at the park without having to rely on USGS. If you don't know how, I will provide the information you need and certain things you should look out for in this video. So just stay here, keep listening. We're about to get in the small portion. I'm going to do some reading, not a whole bunch. I'm just going to go over just a little bit of the history of Yellowstone. As I said, I want to make these as educational as possible, but also I'm doing my best to try to keep your guys' attention. I appreciate all the feedback that I'm getting. I don't mind if it's rude or anything, as long as you're actually trying to be honest and critique me. If you're being rude just to slander me or to attack me, of course I don't like that. But if you're just being brutally honest, basically, yeah, I'm all for that, because I'm the same way. Now, back to what I was saying. So we're going to go over the history of Yellowstone. Yellowstone's world-famous natural history is marked by such colossal volcanic events that the reflection in today's landscape are difficult to grasp and impossible to take in at just a glance, even for those familiar with the signs of past volcanism. The features of Yellowstone National Park result from great explosive eruptions and profound collapse of the ground, enormously thick lava flows, uplift and extensive faulting, and the erosive power of flowing water and ice. For more than a century, geologists have discovered and analyzed evidence of the dramatic events that have shaped the land here. When combined with the growing knowledge about how volcanoes work and the never-ending motion of the Earth's surface, the evidence tells a remarkable story of Yellowstone's landscape. The volcanism most directly identified with Yellowstone region has, during about the past 2 million years, built an immense volcanic plateau that straddles a high mountain divide, the Yellowstone Plateau Volcanic Field. This volcanic region has evolved through 3 cycles of voluminous outpourings of rhyolite lava and volcanic ash, each of them climaxing with one of the greatest pyroclastic flow eruptions and the resulting collapse of the central area to form a large caldera. So we'll stop there. Actually, we'll just finish it up. Other eruptions have poured out basal lava flows around the margins of the volcanic field. Large earthquakes occurred just off the plateau, along nearby the Teton and the Hegbin Lake faults, the latter of which ruptured in 1959 at a magnitude of 7.5, causing considerable damage to the region. Yellowstone's volcanism is only the most recent in a 17 million year history of volcanic activity that has occurred progressively from southwestern Idaho to the Yellowstone National Park. At least 6 other large volcanic centers along the path generated caldera forming eruptions. The calderas are no longer visible because they are buried beneath younger basal lava flows and sediments that blanket the Snake River Plain. Now, I'll have this link, so if I was reading too fast or you couldn't understand me, you can go over that yourself. We'll pull up a couple pictures. I've never been to Yellowstone. I'm still, I don't know if you guys know my age. I think I've said it a couple times. So I just turned 25. So Getting up there in age, I know. I really do want to start traveling. You guys don't know much about me, and I may do a video just kind of doing a breakdown of, just kind of myself, giving my own little, my background, my history. But yeah, that's, like I said, for a future video. However, like I said, I'm really interested in actually seeing some of these sites, and I think it'd be really cool. This is columns of basaltic. I'm so bad at saying that word. Lava at Sheep Peter's Cliff at Yellowstone. Oh, that was really cool too. Okay, so now we'll go ahead and switch over to this is more images from the webcams. Yellowstone Volcano Observatory. This is Yellowstone Lake from today. Okay, so, this is where we're going to really get the video started. Right now, I'm using the USGS monitoring map. I am focused in on the Norris Geyser Basin, and we're going to start looking at the temperature gauges. Temperatures, let me play this small clip for you real quick that kind of goes over what we could be looking for at Yellowstone. I played this on Sunday, but I'll play it again real quick for you guys. Get this volume down real quick.
All right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could crack under pressure from the magma below, releasing an eruption. Geologists are also watching the park's geysers, hot springs, and mud pots, looking for drastic changes in temperatures and chemical content.
Okay, so as he just said, they're watching the temperatures and the chemical contents, and that's exactly what we're going to be doing as well. This is Norris Geyser Basin right here. Let me zoom out one more time so you can see exactly where to focus your research if you're doing the same. Although it's not too hard to find, you can just pull up a simple map. Pull it up a little bit. Oops. So here's the lake. If you look right up here. And you can actually tell by the road signs too. There's actually Norris Geyser Road, I believe it's called, or something like that. Yeah, Norris Canyon Road. And right in front of that, that's where we're going to be looking today. So I'm going to pull it a little closer for us so we can get a better look. Off to the right, what do we have? New Power Air. Now all these, I'm going to have this linked as well. These do a decent way of giving you a basic understanding of what's there. Air temperature near New Far Lake. And this is daily, so we'll just go ahead and take that. I mean, it's around 5 Celsius right now. Today is more of a log day. I'm logging all the temperatures, and we're going to keep track of stuff. I mean, they log it on here as well. Same. Oops, close that. So we'll move up now. This is constant geyser. Past 30 days. Constant geysers, the average temperature is about 65. The eruptions, it has about 10-second eruptions that go from about 20 to 30 feet at constant geyser. So now we'll pull down here to Steamboat. Okay, so Steamboat Geyser on average is about 60 Celsius. It is the tallest active geyser. It has eruptions that can last anywhere from 3 to 40 minutes. It also erupts at 10 to 300 feet. So the Celsius output right now, the 15th. Let's see if I can pull up the daily real quick, see what it's at. It doesn't have it. Okay, so the past 30 of the 15th, it was around 15 Celsius. hope that's correct too. Because if it's the average of 60 Celsius and it's 15 Celsius, to me that doesn't make sense. But everything's backed up by other sources, so I'm just going to report what I have found. I'm going to leave everything linked to you guys so you can find it as well, and you can just go over the information yourself. Mainly, we are simply just looking at temperatures. We are just looking if anything's different. We're looking if anything, you know, where the peaks are. So this is the Igneous Geyser. I may be butchering that entirely. I'm not too sure. Igneous is the average is 80.3, and it erupts every 2 to 3 hours, and it also erupts at 4 to 60 feet. So I check Steamboat, check constant, and you can do this yourself. Spring, the opal spring, it's the 92 Celsius roughly. That's what it usually is at, but it just differs. And see, when I pull up all these readings, so the numbers I say, I pulled from, and I'll link them as well, from other like volcano sites. And so when I have two different standards, I don't know which one's correct. I assume I take the information USGS is reporting. So if this is saying 62, then I'm going to assume that's what it is. But I don't. That's not saying that's the average, of course. But let's see if it ever even gets up to what I had reported, just what I had just said. So this is at the spring, and I said it got up to 92. I haven't seen in the past, and this is the past 30, where it even gets above 70. So I need to check my sources and make sure those are correct. However, I'm going to make sure, just so you guys know, I think it's safe to stay with the USGS unless you can find another credible source stating what these geysers average at. However, like I said, take that upon yourself. I want to just make sure I get the information to you, how to do it properly, what we're looking for. And do that with all these. You can do that through the entire park. And those are just temperature gauges. You also have your GPS monitors, which showed its placement, but you want to make sure they're updated. Make sure they're always at 2018. Almost said 2008. 2018. So the average pool temperature at Yellowstone is 140 to 170 degrees. It gets no hotter than 200. There is on average 1 to 3,000 earthquakes at Yellowstone. There's been 3 previous eruptions, and the ground subsides on average 2 to 3 centimeters all around the caldera, and certain areas subsides. So there's a little facts for you. I don't have much more to say on this video. This is more just a research video to give you guys the tools, and I just want to. I wrote a lot of stuff down, stuff I'm going to be paying attention to. Tomorrow I'm going to do a video on Kilauea and Mauna Loa. This video, I just wanted to do another update on Yellowstone. Yellowstone looks fine. Like I said, I've checked all the charts. I mean, there is steady ground lift over, and it's been going on for a while. It's just been going up. I think it may be this one. Yeah, it's been rising for a while now. But that's been reported. There's plenty of other sites that have reported the ground's rising over at Yellowstone. So I don't think that's any new news to anyone. But this video is more about just raising awareness, giving you some more understanding about Yellowstone, checking the temperatures, telling you what you can do yourself, and I think that's more important than anything. So that's all I have for today, guys. I will have another video tomorrow about Mauna Loa and Kilauea, like usual, and they have the new INSARs out, so I'll be able to go over that with you guys as well. Have a great night, guys.